Hi students, yesterday we seen the properties occurrence of metals. Today we are going to learn non-metals. So what are metals? What are non-metals? Non-metals are exactly opposite to metals. How? Right. Now metals are good conductors. Good conductors of heat and electricity, but non-metals are bad conductors of heat and electricity. Right. Now what is conductor? First we will see what is conductor, and then we will see how they conduct the electricity. Okay, what I said, metals are good conductors of heat and electricity. If you remember, I explained yesterday that metals have tendency to lose electrons, right? And when they lose electrons, they forms positive ions, and that positive ions are called as a cation, isn't it? Now how? Suppose I have a metal, sodium. Sodium has atomic number 11. What is the electronic configuration? 281, right? So sodium have tendency to obey octet rule. Octet rule. Yesterday I explained about the octet rule and duplet rule. Once again I'll explain here. Octet rule means to obtain 8 sorry 2 8 18 and 32 electrons in outermost shell means what? Listen here, 281, the 2 is the first shell, second 8 is the second shell, and 1 is in the third shell. So what is the outermost shell here? This third one. And how many electrons are here? 1 electron is here, right? So sodium has a tendency to lose this electron. Why? Because next to this shell, the second last shell have the 8 electrons. So sodium don't want to do the more efforts to gain the 7 electrons, right? If sodium gain the 7 electrons, then it will be 288, but it's too difficult. So sodium think that if I took the 7 electrons from other metals or other non-metals, then I required a more energy, and he thought that I don't want to waste my energy. So he has always tendency to leave the or to lose the 1 electron. So sodium loses its 1 electron, then its electronic configuration is 281, and 1 electron is removed from him, that shown by the plus sign, and whatever electrons are lost by that metal, that's shown by the number. So plus 1 electron is lost by the sodium metal, right? So and 2 8, that is octet rule get complete here. Now suppose I have a chlorine metal and that has atomic number 17. What is the configuration? 287, right? Now here chlorine thinks that to lose the 7 electrons, it is too difficult for me, so it is better to take the 1 electron and make the 288 electronic configuration. So chlorine tried to take the 1 electron, so in 1 electron, and it makes the 288 configuration. Now chlorine gains the 1 electron, so the sign is given here, or it forms a negative charge, and one charge is there because 1 electron took by the chlorine, and then its electronic configuration is 288, that is outermost shell completes or obeys the octet rule, or octet rule is completed here, right? So now in few metals the outermost shell have the extra free electrons, and these electrons, when are they free, they are transferring the electricity in that metal. Suppose this is the copper wire, right? Copper wire. Now copper wire, what will happen in copper wire? Copper is the solid material. So here one atom, here one atom, here one atom, here one atom, here, ऐसे पूरा one atoms are filled in the copper wire, right? All wire is made from the such a compact structure of atom. Now you are supplying the heat or electricity, then what happens? The free electrons start to vibrate at the place, because the external force gives it energy, and that accepting that energy by this electron or atom, that start to vibrate. Now when it vibrates, it collides with another atom, then this collision is transferred the energy up to the next end. In this manner, the copper wire allows to transfer the heat or to transfer the electricity through it. Because of that, metals have tendency to transfer the electricity, because they have the free electrons. If question is asked in exam, why the metals transfer heat and electricity, then what is the reason? The free electrons present in the metal allows to transfer heat and electricity. Fine? Understood? What is the reason? Free electrons are the reason to transfer the heat and electricity through the metal, right? Now in non-metals, what happens? These free electrons are not available. In non-metals, these free electrons are not available. Because of that, non-metals have always tendency to not to pass the electricity and heat through them, right? They have the tendency to absorb that heat and electricity in them. So non-metals are bad conductors of electricity and heat, and when they have always tendency to gain the electron, so here chlorine gains electron, that means chlorine is non-metal. In such manner, bromine gain electron, so it is also non-metals. Understood? Now what are the examples of non-metals? So first example is hydrogen, then second example is nitrogen, then third example is oxygen, then carbon, then sulfur, right? All these examples are in your syllabus, you have to study them properly. So what is hydrogen? Actually the percentage of presence of hydrogen is more in environment or in universe. So it is represented by the H letter, and it helps to burn by reacting with oxygen. Then it forms H2O, that is water. When it combines with the oxygen, it forms the H2O. Hydrogen is also found in petroleum, natural gas, then coal. In all these substances, hydrogen is found. Natural gas, coal, and petroleum. In these three contains hydrogen, right? So nitrogen. Now second one is nitrogen. Understood? Hydrogen is abundant in a universe, and which is represented by the symbol H, and it helps to burn when it combines with the water, or it reacts with the air, and when it combines with the oxygen, it forms the water, right? Now nitrogen. Nitrogen also present in the atmosphere, but it present always in a free state, and it represented by the symbol capital N. And it is also exists in the form of compounds such as nitrates in combined state. It is nitrates, NO2. In this form, it is present in the atmosphere. Now oxygen is also abundant in the atmosphere, and it is represented by the symbol O. And it also occurs in nature in a free state. It also occurs in the nature in a free state. Atmospheric, whatever the atmosphere present around us, it's a 21%, 21% we can say, atmosphere is formed because of the oxygen. So 21% oxygen is present in the atmosphere. It is easy. 21% oxygen is present in the atmosphere, and it combines as like the hydrogen. Hydrogen is in a free state, but nitrogen is in a free state and in combined state. Similarly, oxygen is also in a free state and also in a combined state, and when it combines, then it forms the oxides, carbonates, and silicates. Listen carefully. What are the examples? Hydrogen, nitrogen, oxygen, carbon, sulfur. Right? These are the non-metals which are in your syllabus. But when we study about the nitrogen's percentage is more in the atmosphere. It is abundant in the atmosphere, and it helps to burn. It reacts with air, and it helps to burn. When it reacts with oxygen, it forms the water, H2O, right? And it is always formed in a natural gas, coal and petroleum. Now second one is nitrogen. It is also in free state and in combined state, right? And it is represented by the capital letter N, right? In free state it is N, and in combined state it is nitrates and nitrites. Oxygen also abundant in the atmosphere. That is 21% oxygen is present in the atmosphere. It is also occur in a free state and in combined state. When it is free state, it is always O2, but when it is combined state, it forms oxides, carbonates and silicates. Now carbon is represented by the C, right? And it is always exists in the native state, that is diamond, graphite and fluorines. So three types of carbons are present in the nature, that is diamond, graphite and fluorine. Diamond is the pure substance, graphite also purest form of carbon, and in the when it form in a combined state, it forms the carbon dioxide, carbonates and bicarbonates. Okay, carbon is represented by the C. Pure form of carbon is diamond, graphite, fluorine. These three are forms of carbon, and when it found in a combined state, that is CO2, that is carbon dioxide, carbonates and bicarbonates. Now last one is sulfur. Sulfur represented by the S letter. Sulfur represented by the S letter, and it exists both free state and combined state as sulfide and sulfates. Free state and combined state. When it is in combined state, it forms sulfides and sulfate. Understood? Now we will take a review. Non-metals are nothing but the exactly opposite property of that metals. Now they are not, or we can say, bad conductors, right? I explained all the things. I hope you all understood about the uh, non-metals. So here we are stop our session. Tomorrow I will take the metalloids. Thank you. Bye.